Hi, everyone. Such a pleasure to be here with you today. My name is Ubiratan. I was born and raised in Brazil, but today I work and live here in Barcelona, Spain. So such a pleasure to be here with you today. Uh, I'm going to talk about GitHub Actions, right? And how we can make the most of it. We're dealing with CI and CD for Android projects. But before that, oops, can I pass my slides? I can. Before that, I'm afraid that my presentation is quite packed for 40 minutes. So I'd like to invite everyone to join our conference group on Slack, right? We have a channel there related to this talk, and I'd love to see any questions you may have there. If I have some minutes after finishing, for sure I will answer all the questions that I can here, but otherwise we can follow up on Slack as well. So yes, let's start. GitHub Actions, right? So what is GitHub Actions? The quick answer is pretty much a new CI/CD product. Not new, but okay, compared with solutions like Jenkins, is somewhat new product. This product is offered by GitHub. It's quite well integrated with GitHub. And yes, because it's not a super, let's say, old solution, eventually it has some limitations here and there, but overall is a very promising solution, especially if you use GitHub as your version control system, right? I do think that the easiest way to make the most of a tool is understanding a bit how it works. And therefore, I'd like to talk about the platform model that GitHub Action offers, namely the building blocks, that we have available and how they relate with each other. I would say that in order to understand GitHub Actions, we need to understand 5 concepts, right? If we understand well these 5 concepts, we are in a very good place. So we need to understand what is a workflow, what is a job, what is a trigger event, what is a runner, and last but not least, what is a step. And the relationship that we can find between those abstractions is pretty much exposed here in this diagram, right? But first things first, let's start with workflows, right? A workflow is a high-level abstraction in GitHub Actions, right? And it's pretty much a container for pipelines or jobs, if you prefer, right? If you worked with CI/CD before, you have probably this concept of a pipeline with yourself, right? So that's it. A workflow is an abstraction, a container over pipelines, right? We will learn more about jobs in a minute, but the important part here is workflows define more or less the entry point for your pipelines, particularly on top of trigger events, right? In GitHub Actions, we have a plentitude of triggers that can eventually fire your workflow, right? Not only some of the classical ones tied to the version control system, like, okay, a branch was pushed in the head, or a branch was tagged, and so on. But GitHub Actions also supports a couple of events, actually several events, which are pretty much related to the GitHub platform itself. For instance, you can trigger a workflow when a GitHub release is created, or you can eventually trigger a workflow when someone fires an API call to the REST API of GitHub Actions, and much more, right? So this is pretty much how workflows behave. They are a container they receive the trigger events, and eventually they map such trigger events to one or more particular jobs that should be executed accordingly that event, right? So not that hard to start. Okay. In this case here, just an example, we have a workflow called internal library. This workflow is pretty much defined only by one pipeline, which is called build. A pipeline contains a bunch of steps. We will see more about that in 1 minute. And in here, in this example, the workflow is triggered by the pull request event on GitHub, right? So we have one event triggering one job wrapped by this particular workflow, right? Eventually, we could have a different workflow. We could have an internal library workflow that actually is composed by two jobs. A first one called build, a second one called publish, right? And particularly, this workflow is mapping the tag event, where we want to build the code of our internal library first. And after that, only after that, we can publish that particular artifact related to our library, right? This means that workflows do more than just wrap jobs. Workflows also are in charge of defining coordination between jobs. We will learn more about that in a few minutes as well. Interesting part here is that a workflow is defined inside a YAML file. Particularly, all the workflow files should live inside this .github/workflows directory in your root project, and we can have as many of them as we want, right? So in general, it's a good idea to try to, let's say, split a bit responsibilities between workflows, so the pipelines becomes easier to change and also easier to maintain, right? I mean, YAML is not that terrible as soon as you get used to it, but at the same time, we don't want to deal with thousands of lines of YAML files. I mean, it's not a good experience, so to speak. So it's a good idea to pretty much split workflows if we can. So yes, now that we talked about workflows, it's time to learn more about jobs, right? As I've mentioned, the concept of job in GitHub Actions is really easy to grasp because it matches our idea of a pipeline, right? Or if you prefer, a sequence of atomic tasks that you want to execute, right? One step after the another, right? In GitHub Actions, the atomic task that you want to run as part of your pipeline is called step, right? And we have several types of steps that you can define inside your job, right? But before going deep into steps, an important concept that also comes forward alongside with the concept of a job is the concept of a runner machine, or just runner, right? In GitHub Actions, each job will execute inside a runner machine. And eventually this machine is provided by GitHub as part of the product, or is self-hosted by you or your team inside your infrastructure, right? The runner machine is just a computer with the GitHub runner software installed and configured there, right? That's it. So, but it's quite important because every job must have its runner, right? You can't have jobs without runners. That's it. We will also see more about runners in a few moments. But now, talking a bit about steps, right? As I've mentioned, we can have several types of steps in GitHub Actions. For instance, a step can be a shell script command, let's say invoking a particular Gradle task, right? But not only that, a step can also be something we called composite action, right? And a composite action is pretty much a piece of shell script packaged as a reusable component, right? I won't explore composite actions in this talk, but they are quite useful, right? It's quite common to see scripts kind of being, I don't know, duplicated and, I don't know, triplicated or copy and pasted several times over and over across several repositories. And eventually we could just pack that script in a composite action and distribute that script as a composite action in our organization, for instance. In addition to the composite actions, or if you prefer, the simple composite actions, we also have the nested composite actions, right? This particular one is a new feature. It's something that landed kind of 1 month ago, right? And so it's not super well documented and so on, but it works. We are using it inside N26, for instance. But yes, a nested composite action is a way to kill boilerplate from your YAML files, right? It promotes our next level of abstraction in terms of reusability of components, right? But I won't talk about this feature in this presentation. Although I have some examples that I can share with you if you want. Just let me know on Slack, for instance. Last but not least, a step can be defined as code, right? It's not a command that I am invoking. It's not a shell script that I am running and wrap it as an action. It's pretty much code, right? Code that I wrote, let's say, using Python or, I don't know, Kotlin or JavaScript or whatever programming language I want, right? Curiously, this is pretty much the concept that pretty much brands the GitHub Actions platform, right? Because we called by GitHub Action pretty much a step defined by code, right? So a piece of pipeline, a piece of automation written in a high level language, right? And a piece of automation that I want, let's say, to share across multiple workflows or even multiple repositories. When we talk about the runner machine, right? It's quite important to understand the relationship between the runner machine and the type of the GitHub action that such a machine can execute, right? As I've mentioned, a GitHub runner can be either provided by GitHub or self-hosted. And it's just a machine with the GitHub agent installed there, GitHub runner agent installed there. And such agent can be installed, for instance, in a macOS machine, in a Linux machine, or in a Windows machine. But although you can install the software pretty much on the 3 major operating systems that we have, not every runner can run every GitHub action, right? Particularly, we can wrap GitHub action as a Docker container action, right? And this is most likely the way to go when you want to use your preferred programming language to define pieces of your pipeline. Let's say you write a particular automation, I don't know, some kind of changelog generator, I don't know, using Kotlin or Python or anything that requires a particular execution environment. In order to make such execution environment, let's say, self-contained, the way to go is wrapping that particular automation as a Docker container. But Docker container actions can only be executed on Linux machines, right? They are not supported on macOS runners by default. They are not supported on Windows runners by default. So the important message to share here is if you want to have, let's say, the most broad support for any type of actions that eventually you want to implement or you want to use, most likely Linux runners are the way to go, either provided by GitHub or self-hosted, right? So yes, this was pretty much a crashing course in the basic concepts of GitHub Actions, right? And now that we finish such concepts, probably we can see an example on how we pretty much implement a pipeline or a workflow with GitHub Actions. In order to tackle this, I chose an example from the open source world. In this case, the Signal app for Android. This particular project uses GitHub Actions and has a couple of workflows defined and being executed there regularly, right? I particularly interested in the Android CI workflow, right? I took the file and pasted the configuration here, right, in the slide. We can see this is the full configuration of this workflow, Android CI. We can see that it's not that big, so it's a good example for us. Let's understand what's going on here. So, first of all, every workflow should have a name, right? This is important because the name will appear in several places inside the GitHub Actions UI, right? But okay, it's straightforward. Just give a name to your workflow and that's it. After that, we can see some configuration related to the trigger events, right? So we can see that this particular workflow will trigger for pull request, which means that, okay, when someone creates a new pull request, this workflow will trigger for sure. And it also triggers for some Git pushes in some particular branches, like the master branch and some release branches as well, right? This particular workflow defines only one job called build. And this particular job is attached, or it will run in a runner machine, which is a Linux runner machine provided by GitHub, right? Because it's an open source project and so on. So quite straightforward as well. Then we have the pipeline, or pretty much the sequence of steps executed as part of such job, right? Such build job. So we can see here, I am pretty much focusing here in the important parts. And we can see that in the very beginning, we have a step where action provided by GitHub, in this case, actions/checkout. This one is provided by GitHub, right? This one is pretty much set there in order to check out the source code of the repository inside the runner machine, right? And after that, there is another action being executed. This one also provided by GitHub, which pretty much sets the Java environment to make sure that this build will run with JDK 11. That's it. So most likely in our Android projects, we start our workflows, or better than that, we start our jobs with something like this, right? We check out our code and we configure the Java environment. After that, the job define a few steps. Another step using custom action provided by Gradle that makes sure that the binary for the Gradle wrapper, which is usually committed in the GitHub repository, is not tampered somehow. It's pretty much a security related action. They run a particular command from the SDK manager to uninstall the latest Android platform. Don't ask me why they do that. I have no idea. But yes, and after that, they run a simple Gradle task to pretty much to execute a full Kiwi build, right? Last but not least, the workflow will pretty much, well, the job, sorry, will pretty much execute conditionally a step, and the condition that trigger such step is the failure, right? This type of built-in functions that are supported by GitHub workflows and GitHub jobs and so on, they are all documented and we have a bunch of them, right? But the point here is, okay, when the job fails for some reason, the job will try, when some step fails, better than that, the job will try to collect build reports, because eventually the job failed because let's say some test is broken, let's say, and upload such build reports into the particular storage for this build in GitHub Actions, right? So that's it. So we have a straightforward workflow that supports several triggers, defines only one job, has 5 mandatory steps and 1 conditional step, right? I really recommend you to check out the Signal Android repository so you can learn more about that as well. As I've mentioned, we have GitHub Actions, and GitHub Actions are pretty much designed with open source model in mind, right? Which means that every single time that we see a statement like, okay, uses actions slash checkout or actions slash cache, then at v1, this is pretty much a coordinate to a GitHub repository and a particular tag inside that repository, right? Or a particular branch reference is inside that repository, right? So yes, it is a good idea to pretty much check out, no pun intended, the source code of actions that we use, right? And just to highlight, it's also possible to have privately distributed GitHub Actions, but I won't cover that topic today, right? Since it's not officially supported by GitHub right now. For instance, let's say that you are interested to learn how the action cache provided by GitHub behaves, right? A tip that I can share with you is that you can go to the repository of that action and look for the action.yaml file. That particular file defines the public API for that action, which means that it defines both the inputs and the outputs, usually with good descriptions about, okay, what that particular input means, right? If that input is required, if it's optional, if it accepts, let's say, a default value when it's optional, these kind of things, right? So yes, we can learn, for instance, that okay, in the case of actions slash cache, we can't execute such an action without providing the path and the key that we want to use in order to address a particular entry in that cache, right? So yeah, useful tip. So we covered pretty much the basics of GitHub Actions, and now it's time to talk about how we can use GitHub Actions with large projects, right? We know that Android projects nowadays can be quite big, sometimes with dozens of engineers working in the same code base inside a single repository, and so on. So the question is, can GitHub Actions handle CI workloads of my project? The answer, of course, it depends, right? And we will learn why. So to get started, we first need to learn more about the runner machines offered by GitHub, precisely the ones like Ubuntu latest or macOS latest and so on, right? When we go to the official documentation of GitHub Actions, we can learn that such machines are not that powerful, right? Most likely, we have notebooks or desktops more powerful than such machines. Even in the case of macOS Runner, which is a bit more powerful than the Linux or Windows runners provided by GitHub, right? So yes, this is the status quo right now. For sure, an option to work around of that is implement your self-hosted runners, right? So you can assign a super powerful EC2 instance to run your workflows, and that's it. But eventually, this is not trivial. This requires coordination with your infrastructure team and so on. So yes, eventually this is not an option. Just to share some let's say news around this topic. This is tracked inside the public roadmap for GitHub Actions, right? So we can see here that soon we should have more powerful machines coming, and eventually this is the, let's say, roadmap for Q3, which ended yesterday. So yes, probably in the upcoming weeks, we will learn more about this, which means that we will probably have more powerful machines provided by GitHub, right? Meanwhile, despite using a self-hosted runner or eventually a big runner machine that GitHub will announce, we still face a question. Can we scale our builds on CI strictly on top of bigger machines? I would say that the answer here is no, right? Because bigger machines for sure provide a better way to scale workloads for big jobs, let's say, jobs that execute a lot of steps or eventually heavy steps, I don't know. But we should also consider that we can split a big job into smaller ones and coordinate between them at workflow level. Since each job will run in a dedicated runner machine, this is the way to scale execution sorry, when powerful hardware eventually is not available, right? And we can learn how to do that. I would like to start with a very straightforward use case for horizontal scalability of workflows, which is called build matrix, right? It is one of my favorite features of GitHub Actions. It's quite powerful and quite handy, right? To explain more about build matrices in GitHub Actions, I will take as an example the Detect project, right? So Detect is a static analysis tool, quite common in Android projects, Kotlin projects, and so on. And in the case of Detect projects, they use GitHub Actions extensively. Oh my God, I don't know English. So yeah, particularly I am interested in a workflow called pre-merge, where they use a build matrix, right? If we look a bit more carefully into this workflow, we can see in the left bar all the jobs that run as part of that workflow. And we can see that we have a job called Gradle, right? Which run several times, but with different configurations, more or less, right? So different, it's like a combination of the operating system with a number, let's say 8, 11, or 17, right? To understand what we have here, let's see how this workflow is defined. If we go to the configuration file, we can see that in the definition of the Gradle job, the configuration is pretty much opt-in into the matrix strategy. And as part of the matrix, we have a definition of the dimensions of such matrix. And the dimensions are pretty much two arrays. One array naming the proper operating systems or runners, right, that will execute such job. And another one is pretty much the JDK version. And here we have the, let's say, the latest 3 long-term supported versions for JDK, right? 8, 11, and 17. And we can see that such parameters defined by the matrix are pretty much associated with, I don't know, with some statements inside my workflow definition. For instance, the job will be configured on the fly according to the according to one of the value of the matrix, one of the values of the matrix, right? Same for JDK version and more things, right? So in the end of the day, okay, so here is pretty much some of the steps of that workflow where we can see that OS is also used to configure the cache, and JDK is used to configure the Java version in the setup Java step, so on and so forth. What we have with a build matrix is pretty much something like this. We have the dimensions of the matrix, and for each cell of that matrix, a job will be spawned. Therefore, that job will execute in a dedicated machine, and we can execute the same job several times with different configurations, right? This is build matrix. I do think this is an awesome feature. But yes, life is not so nice with us. We have a bunch of limitations. For instance, we can see that the number of parallel or concurrent jobs that we can have when running with matrix is eventually only 256, and it also depends on your GitHub Enterprise plan and if you are using or not macOS runners, right? All right, so build matrices are for sure a way to scale our workflows, but I would like to talk about custom topologies, right? This is a very interesting topic, quite unexplored, I would say, and for sure something I would love to share here today. A build matrix tackles the case where we want to run the same job. We want to run the same job with different configurations, right? In different machines, so we have parallel execution. That's cool, and okay, it works. But eventually, we have different jobs. We have different jobs of different sizes, and not necessarily all the jobs, they pretty much fire when the trigger event just kind of triggers the workflow. Eventually, a job is waiting for the execution of a previous job or more than one previous job, you know? And then we have this kind of architecture that we called by topology, right? A workflow topology or a pipeline topology. So yes, how do we define topologies in GitHub Actions? This is interesting because we know that every job we execute inside a runner machine. Hence, we can have several levels of parallelism also with topologies. In order to achieve that, we have this special keyword defined by the GitHub Action syntax, which is needs. So no pun intended here, needs is everything you need, right? So let's see here an example. We have the first job, we have the second job, and we have this easy definition that tells to GitHub Actions runtime that the second job will execute only when the first job complete, right? If we can do that, we can also, let's say, define array, and we have something that we call as funning, where a given job, in this case third, will wait until the first job and the second job finish before executing, right? If we can fan in to a job, we can also fan out from a job, which means that, okay, after the first job finishing, third job and second job will start the execution, right? Here I have an example of a project of mine, shameless plug here, where I use topologies, right? I am running a bit of time, so probably I will skip a bit the configuration. So what we have here is a job called static analysis, another one called unit tests, another one called assemble APK, another one called espresso prepare. In the case of assemble APK and espresso prepare, they both of them upload some artifacts in the storage of the build in the workflow. So I will explain why this is necessary. So pretty much such jobs can share outputs with a job that is about to execute, right? Because we need to remember each job runs inside a runner machine, and the machines are isolated. So they don't share state, they don't share outcome between them. So if you want to have such a sharing, in the case of outcomes or artifacts, a good way to achieve that is uploading such artifacts in the storage associated with a particular workflow, right? Then we have here a particular job called acceptance tests, and we can see here that such job will fetch those artifacts, but and in order to execute the espresso tests, but more important, it needs all the previous jobs to complete successfully before it starts its execution, right? So yes, I am almost out of time. I have kind of less than 5 minutes, so I'd like to share a couple of Android tips, right? Particularly related to Android. The first one is related to emulators, right? Emulators on CI are usually tricky. On GitHub Actions, this is not different, right? And particularly, we have this well-known action provided by one of the members of the community that makes the task of spin up an emulator in the CI a bit easier. But there is a catch. This action is recommended to be used only with macOS runners, right? And right now, this is related to some limitations in the machines provided by GitHub, particularly the Linux machines provided by GitHub, since they don't support nested virtualization, right? Since, therefore, if we spawn an emulator in a Linux machine in GitHub Actions, such emulator won't run with decent performance, right? Eventually, this will change with upcoming runners, as I've shared in the GitHub public roadmap, or eventually you can tweak around this limitation with self-hosted runners. So yes, why this is important? Because if you are paying for GitHub Actions to build your private project and so on, you need to be aware that such machines are the most expensive. They have the biggest minute multiplier. They cost, let's say, 10 times more than a Linux machine. And yes, and we know that instrumentation tests are pretty much heavy. They take a lot of time and they fail a lot. We need to rerun things, so on and so forth, right? So be aware of that. On top of this tip, I would recommend you to define some timeouts for your jobs, right? This is supported. It's quite easy to define a timeout. We can just go there and use the particular keywords, timeout minutes, and set the number of minutes, and that's it. And why is that important? Because by default, the default timeout for a job in GitHub Actions is 360 minutes or 6 hours. So can you imagine what happens when, let's say, you spin up an emulator and then the emulator does not boot for reasons, because this happens, and then you get feedback about the failure only 6 hours later, and you paid for those 6 hours without actually running anything. So it's a shame, right? So please set timeouts in your jobs. There is a particular topic which is quite interesting, which is Gradle Caching, right? I won't dig a lot because I am almost out of time, but what I can share here is that caching on CI is not trivial, for sure, right? There is a lot involved when we can't have, when we don't have shared state between machines. So we have hard questions around, like, how do we compute entry keys in order to maximize cache hits? What should be cached per execution? What should we segregate these cached files per job or not? And more questions, right? So it's not trivial. we have a bunch of options around to implement caching, right? I'm sharing a bunch of them, so I won't stick to every single feature here, but what I want to share is that, okay, we have a plenty of options. Some of them probably are easier to use. Some of them are totally customized, like the actions cache provided by GitHub. So it's totally custom and so on. So in a rule of thumb, I would say that the Gradle build action provided by Gradle does a good job when talking about caching. And most likely, if you have a very simple project, the built-in support for caching provided by setup Java action, it's quite decent. So you can go with it. I will pretty much skip this topic because I am out of time. I have so many slides here that I don't know how do I skip. Maybe I can, okay. This is here is how we can tweak a particular execution according to the runner machine, right? So now I am in my final remarks. So yes, too long, don't read. We have this open source model for reusable actions, which is quite powerful. GitHub Actions provide a good model that you can use in order to scale your pipelines both horizontally and vertically. It's a really an awesome option for open source project, also for open source libraries. CI caching is hard. I didn't dive on this topic, but trust me, it's not trivial. And most likely we have unique challenges for big Android projects like the caching itself, dealing with emulators, different type of runners, and these kind of things. I am this guy, Brazilian computer scientist. I work at Entrance 6 here in Barcelona. Here we have my social links like Twitter and website. I really appreciate you for having me here today, and thank you so much.